Hello guys, KNOCKCAT this side. So today we are going to solve GFG problem of the day, and that is maximum index. The problem states that we are given an array of n positive integers and we have to find the maximum of j minus I such that it follows a condition of our a of I should be less than a of j and I should less than j. So let's come to the whiteboard. So what does that mean? We need to maximize our j minus I. That means we are at I and we are at j, we need to find the maximum distance between I and j such that my a my element of I is less than equals to my element of j. My element of I is less than equals to element of j. So if I look for the first test case, it is 1 and 10. 1 and 10 follows a case of, let's say I is 1 and j is a 10 here. I less than j and 1 is less than 10. So j minus I, 1 minus 0 and 1. We get the answer as 1. So let's took this case and that will help you understand more. So let's come to this case directly. In this particular case, let's say I'm at 34 I, and if I'm at I, a nice solution would be like I check for an element from the very behind. Since I need to maximize this window, so I will check from the very end an element which is actually greater than 34. So 80 would be greater than 34. So because 1, 2, 3, 4, 5, and we will get actually 5 terms. Similarly, if I'm at 8 and I check for 8 to get the greater answer, I will actually check from the very end and I will see any element I can find which is actually the first element from the end which is greater than my 8 or equals to 8. So if we go, 33 would be greater than 8. 8 is less than or equals to 33. And if I go on counting a j minus I, you will say it is at 1, 2, 3, 4, 5, 6, 6 jumps. And this is a very optimal answer where we get our answer as 6. So the naive way would be you can iterate for every pair from I equals to 0 and j from I plus 1, and you can check for a condition like for loop, and you can actually maximize your answer as maximum of answer comma j minus I. So this is you can do in order of n square. If you do this also at finding the at I, and from the very end you will look at the first element from the end that is actually greater than j, then also you will get to order of n square. So this is a very naive approach, and I hope you can code at it. I will also show the code at the very end of this brute force. But I hope if you come here, you already know how to code this. So we just move to the optimal one, and how we can do it in more optimized way. So we can actually do it in order of n. So let's say we are looking to maximize the distance, first point. And let's say if I'm at I and j, if I and j follows the condition, what does that mean? I will update my answer, and if that follows, I will increase j. I will now look for I and j. That do my I and j follow the condition? If it again follows the condition, I will again look for j. If my ij, now my I and j do not follow the condition, so I move my I. I am getting some window type approach. I am looking for a point I and j. If I to j, like I and j follows the condition, that means this is my answer. But at some point, if I is here and j is here and I do not, this do not match, so I will try moving my I. I hope you are able to figure it out. This is the sliding window approach that looks for 2 pointers, and since we have to maximize the distance, and to maximize this distance, the condition should be follow is I less than j, a of I. should be less than equals to a of j. Saying distance would not be appropriate, but this condition is actually maximizing the window only. So if I'm at I, if I and j follows the condition, I will increment my j, and if at some point it do not follow the condition, I will increment my I. So now this is how this is like actually sliding into. But now how we'll actually check the condition of a of I less than a of j. So for this, we will actually maintain two arrays which will be our prefix minimum array and suffix maximum array. The definition for prefix would be the minimum element from 0 to I. Prefix of I will say prefix of I would be the minimum element from 0 to I, range 0 to I, and suffix of I would be defined as the maximum element I have from I to n, in the range I to n. Suffix of I will tell me the maximum element I have in range from I to n, and prefix minimum will tell me the minimum element I have till I. Now, let's say if I know what is the minimum element here, and I know through my suffix if I'm standing at a point I, so at this point, let's say I'm at j, and I know at this point what would be my maximum element in the very right hand in this array. If I'm at j here, so it will tell till here what is my maximum. And if I'm I here, so if my I follows the condition that j actually don't tell, we are not comparing I and j, that what are at I and j. I am actually considering about j is actually maintaining maximum till now, I is maintaining minimum till now. So if I and j, if prefix of I happens to be less than is equals to suffix of my j, that means this is going to be our answer. This has to be our answer. We will update our answer. But you might be thinking that if j is not less than, actually we are not considering about either this j follows a condition, because this suffix of j guarantees that there is some element which is actually greater than my prefix of I. This j guarantees, because it is storing the maximum till now, it guarantees that I have some element which is actually greater than suffix of j. So we are not bothered about this condition I less than j, but we are bothered about the minimum till now. Is it less than the maximum till now? If minimum till now is less than maximum till now, I can update my answer j minus I. And if this condition follows, I will look for increasing my window. If this condition fails, that means this condition fails, that means the minimum from here is not less than that means if my minimum happens to be greater than maximum, then we will move our ith pointer, because if we are maintaining minimum in this array, the prefix max, if at till this point my minimum is now greater than the maximum, do it form a valid pair of ij where a of I is less than a of j? No, because we are actually maintaining minimum, and now the minimum till now is also maximum than this element, which is actually maintaining the maximum from I to n. So if that's the case, I will increment my ith pointer. So we can actually go for a sliding window approach, saying while I do not reach till end, while I do not reach till end, if my prefix of I, if it is less than my suffix of j, if that's the case, update answer and increase my j, because suffix of j do not guarantee it's only guaranteed that yes, there is some element in the righter half which is actually greater than my prefix of I. Because this will be going to answer, but we will plus j because something better can still we can get better. Let's say j is here, and this is the maximum element till now, and later we have minimum, but still this j is following a pair with this. So one case is j is here, and that is maximum. So we are very sure that it will give us maximum answer. But what if this j is the maximum element? So still this j follows a condition, so we'll update the answer. Next time, if this j was maximum and I came to a j which is minimum than this and it violates the condition, so this condition will never be true. So if my previous of I is less than previous of j guarantees that I have some element in this range which is actually maximum than this. So update the answer and look for an optimal in the increment my j so that I can find a better answer. And if that not the case, if that not the case, actually this is here. If that's not the case, increment my I because that means the minimum till now have become maximum than the writer half max. The minimum till now, the minimum till now is larger than the maximum in the rightmost window. So it's better to eliminate this so that I can find a better minimum because I am maintaining prefix minimum. So I will move my I forward in order to find better minimum. In order to find better minimum. So this is the approach. Let me go with the dry run fastly so that you can able to relate what this actually means. Let me erase this fast. Yeah. So let me. So what would be the prefix array? Prefix array. Let's say this is the prefix array. This is suffix array. Okay. 34. Prefix is the minimum till now, the minimum of the minimum till now, and the current element. Current element is 8. Minimum till now is 34. Minimum is 10. Minimum till now is 8 and current is 10, but still 8 is minimum. Again, 3 is minimum than the previous minimum. Then we came to 2 is minimum than previous minimum. 80 came, but 2 is previous minimum is still minimum. 80, 30, again it is minimum. 2, 1 came. 1 is better than previous minimum, so 1. Okay, let's make the suffix accordingly. Let's make the suffix accordingly. Suffix I will iterate from behind because I am looking for a maximum till now. I am looking maximum max in this range. Okay, so maximum 1, 33. Maximum till now is 1 and the current element maximum is 33. 30. Maximum till now is 33 and current is 30. So 33 is 80. Maximum till now is 833 and current is 80. Max of both is 80. 2 will get 80 will be maximum. Again we get 3, 80 is maximum. We came at 10, still 80 is maximum. 8, 34, still 80 is maximum. Okay. Now I'm at my pointer I, j. Is 34 is less than 80? 34 is less than 80? Yes. Move my j here. Answer will be updated as 0, 0. J minus I. Both are at 0. 34 is less than 80? Yes, it is. Move pointer and this time j minus I. Answer is 1. 80 is 34? Yes. Yes, 80 also, 80 also, 80 also. Till here it is fine. And 0, 1, 2, 3, 4, 5. It is at 5. It is at 0. 5 minus 0. We can answer as maximum till is 5. Now see. This is saying the maximum till now. Now we came at 33. Prefix. Maximum till now, sorry, minimum till now is 34 and maximum till now 33 is do not follow because now in my prefix array is become maximum then this array which is actually maintaining maximum. So I will move my pointer here because 8 now check for 8. 8 is less than 33. Yes, 8 is less than 33. Condition follows. condition follows, and if you check for the answer, it is at one position, and it is at 6. 6 minus 1, we again get 5. Now it came to 33. 33 is 8. I'm here. 33, 8 is less than 33. Yes, it follows, and it is at 1. It is at 7. We get 6 as answer. We move our pointer at 1. Now 8 is greater than 1. We will move. 3 is greater than 1. We will move. 2 is greater than 1. We will move. This is, this is 1. 1 is less than equals to 1. We will again update our answer. We will get 1 from here, but our max is here. And since it would be like 1 is less than is equals to 1, j will come to end. And since j is now equals to n, so our while loop will be terminated and we will get 6. So the time complexity is like we will move in first order of 2n. We will move order of 2n, and you see our jth pointer will also come to n. Our ith pointer also came to n in the worst case. So 2n, and space complexity is also order of 2n. Why? Because we are using two arrays, prefix and suffix. So let's do the code. Like I have already done the code. Actually, this is the video is like I am recording it twice. So like I maintain a prefix array, initialize it with int max because we are maintaining minimum in it. Suffix array, I initialize it with int min because I am maintaining maximum in it. Same thing. Prefix of 0, I make it as a of 0 because we are iterating from very beginning. And now pref of 5 will be minimum till now and the current element. Minimum of minimum till now and current element. Minimum till now and minimum of current element. Current minimum is 8, current element is 8, minimum till now is 34, minimum of both. We got 8. Similarly, suffix I iterate from very behind, n minus last element would be same. And now I am checking maximum till now and the maximum of current element. So this is how we make suffix array. And similarly, the same idea driven till my j less than n. If my prefix of j, if my minimum till now is less than maximum till now. If my minimum till now is greater than maximum till now. 8 is minimum till now is 8, maximum till now is 80. That means there is somewhere 80 in this array. So update the condition and look for a better answer at plus plus j. If this do not follow condition, that means now my minimum from left actually become greater than the maximum from left. So we'll move our add pointer in order to find a better minimum, a better minimum, a better minimum. So till we come to n. Time complexity is order of 2n, which would be like order of n only. Space complexity is also order of 2n, which is the order of n only. So this is the code. And if I show you here, okay, my second code expired, but like this is the code, but and this is an accepted. So I hope you get to understand this video, and thank you. And I will say you to try more some problems on sliding window to make a proper grasp over this concept. So thank you, and knock at this side.